PowerTracks has digital audio features, meaning you can work with WAV files as well as MIDI files. Let's start with something easy like taking a blank sequence and opening up a WAV file. Windows comes with some very simple WAV files, and so a simple example would be opening up one of the WAV files that comes with Windows. It tells you that that tells you that it was an 8-bit file and it wanted to transfer it to a 16-bit file, which it's done. So it's opened this WAV file, it chimes, and we can play it. Very simple WAV file of about 1 second duration. You'll notice if you press the notation button now instead of obviously notation, which can't be done on a file like that, we get a graph of the actual waveform, and you can expand it to be as big a waveform as you want. You can select a certain area and play a selected area, or you could select part of that WAV file and choose Edit Cut and cut that particular section of that WAV file out, and then if you played the WAV file from the beginning, you would hear, or you could choose to paste it to a different section of the WAV file and get that fragment of the WAV file done, or you could choose Edit, Undo, and this sort of thing. So common operations on waves can be done. Now this is clearly a tiny wave that's not very musical, but we'll see how this concept can be applied to other sorts of WAV files which are real recordings. With the PowerTracks, we include some sample WAV files in the PowerTracks directory, such as the demonstration files rock.wav and tutor2.seq, which are very large files indicating they're WAV files. We also include Multi-tracks discs, which are interesting discs, and they come with our PowerPack series, and these are jazz, rock, and blues multi-track audio recordings, which are full songs with 4 instruments playing the parts. So let's have a look at these multi-tracks. Now, if we wanted to just open them up, it would take a while for the entire file to be copied from the CD-ROM. So a faster way to do it is to use this file, WAV files, multi-track wave player, and it'll clear the current song because we're loading in a new one. We can press the load button, go to our CD-ROM, and you can see that this is our blues multi-track disc, and there are 10 songs, each of which is a WAV file, but it's a special type of WAV file which is a multi-track WAV file. And so we could load in, for example, song 10, and then press play. So you'll begin to hear an audio file. So what you're hearing is a 4-part bass, drums, piano, and guitar WAV file, and you can move around to different parts of it, and this is playing directly from the CD-ROM. So the whole point of this is that by pressing the mixer button, you can do things like change the instruments. So for example, to mute a part. Now you'll see when I do an action like to mute that the hourglass happens. And the hourglass happens because there's a buffer that has to run dry before the effect will occur. So for example, if I reduce the volume, it'll take a few seconds. Now if we didn't like that taking a few seconds, we could set an option in PowerTracks, Audio Preferences, Audio Settings, to have quick volume changes. What that will do is have the volume changes occur almost immediately, but it'll jump to the section and it'll be audible a little bit, so we can have it playing. So this way, we can get an immediate mute, but you'll hear a slight glitch because it's got to search the CD-ROM immediately. But you can do things like pan these instruments, and so if you were wanting to jam along, you could say, let's turn the guitar part off. Or you could say, let's mute the piano and let's bring back that guitar, and I'll do the rhythm part myself. This isn't a stereo recording on this demo tape, but you can do panning as well, or mute the instruments, mute the drums, bass, that sort of thing. So this is the Multi-Tracks tapes. Now these allow you more or less to preview them using this part of the program. So if you said, yeah, this sounds like a file I would like to work with, you will choose import tracks to PowerTracks, and then it'll load them into these tracks here. When you choose this option, it has to copy the entire file, which is typically 30 or 40 megabytes, and it's going to take probably 20 or 30 seconds to copy the file. And we'll you see the hourglass, and we'll resume when we're copied. You can see that we've imported these files. The Multi-Tracks is now part of a PowerTracks file, and we can now save this as a typical seek file right away, or we could work within in PowerTracks. For example, track 1, we could press the solo button and hear exactly what it is. Obviously it's the bass track. We could view it except obviously this time we'll be able to see the track as a WAV file. So this is what the bass part looks like, and the same idea applies to any of the tracks. The drum track, the piano track. So you might want to mute these tracks and just hear bass and drums. So basically these tracks work like MIDI tracks in that you can select a certain region and choose copy, paste, and this sort of thing using audio data instead of MIDI data. So it's easy to record an additional track on top of these. For example, we have a track on our C drive in the PowerTracks directory. We made a track called A1. Now this is a track that was from one of the Multi-Tracks, but we got rid of the guitar solo part because we're going to record in our own guitar solo, and this shows you how PowerTracks you can obviously use to make your own productions, or in this case we are augmenting an existing 3-part digital audio track. So this is a digital audio track that has bass, drums, and piano, but obviously it's going to need a guitar solo. So what we're going to do is record our own guitar part on top of this 3. So obviously we have to go to an unused track, which is in this case is 4. You can see that these are audio tracks and this is set to MIDI. So it's important that we change this to audio. And now it's ready to be an audio track, and we can just now put in the name of the track, or we could wait until we're finished. So we could just press record now, and we're going to hear it count in and play guitar now. It's recording this guitar information that we're playing. And at the end of this take, this will add to our other tracks, just like any other track. So now we're finished with track 4. We've recorded our guitar part. We can just type in that it's an audio guitar part here, and you can see there's one event on this track. If we look at an event list, we'll see that the one event is at time 1. Right, basically it started right at the beginning. So now we can see what our guitar part looks like here, and we could start playing it right from where we took our solo. So, we can edit this part or get closer in here, and if we wanted, for example, if we didn't like, if we didn't like this particular part, we could get a little bit closer and say that we just want to delete this part by cutting it out, and then we'll do an edit on that. All these files are 10 to 20 megabytes and that sort of thing in size, so it takes a little bit of time to do these type of edits, but they all can usually be undone in PowerTracks, so we can just play that. So if you want to get rid of that part there, it would be a similar idea, and this can all be cut and pasted in a typical manner. So this track here is free to add in any additional type of information you wanted to it. We could record in a MIDI track on it as well, so we could just go back to the just start from here, and we could play some MIDI data over it. We can add MIDI data to our track. We started off with 3 audio tracks, we added a 4th audio track, and now we can add a MIDI track just by pressing record and just playing along on our MIDI keyboard. So it'll tell us keep take, and we've added 45 events, and we can just look at the notation window, go up a few bars, and then we can see the MIDI data that we played. Probably want to put it in a triplet feel on the notation and have a look. And you can see that as we move around on the audio, the MIDI also moves and stays pretty much in sync. Now we'll add an audio effect to our guitar part. So first thing we do is select a region. This is the guitar is just doing rhythm here. It just starts doing the solo here. So we could start at bar 7 and say go to bar 22, and that's the region that will have the effect applied to it. So we could say let's add some flanger effect, and here we're allowed to choose what type of flanger effect. We could choose a guitar warp. We could preview what it's going to sound like by pressing this button, and we can hear what it's going to sound like. So that adds a typical flanger effect. So that sounds like a reasonable one to do, so we're going to apply it, and it'll apply it to that portion of the track, and when it's done it'll write an undo track, obviously to undo the effect, which is what it's doing now in case we don't like it, and then we'll be able to play the selected region or play the whole track. So here's what it sounds like. Now if we want to hear it with the whole thing, we've added flange to the effect, to the whole track. Obviously we can undo the effect and just hear it the way it used to be, or we could redo the flanger effect. Now we can have an additional effects can be applied to it, such as distortion, etc. And we could choose a ratty guitar and see what all that sounds like. So we can have lots of fun with all kinds of equivalent of effects pedals. It's writing the undo track for that. Nice thing about these effects is that they are separate little programs, and you can, if you read the documentation and you know anything about programming and digital signal processing programming in particular, you can write your own effects. and we include some source code for the existing ones. So you can make some pretty interesting sounds out of the whole thing, and of course now you can save that file. A nice thing about PowerTracks is that it'll save it all in a single file called a seq file, and as we've demonstrated in this example, we have MIDI data that we recorded, we have 4 tracks of audio, and basically you can go up to a limit of 48 tracks. It all depends on your processor. Typically we can get up to between 16 and 20 tracks on a typical Pentium, but it depends on factors like hard drive speed, whether you're doing 22K or 44K, what type of sound card you're using, and other factors, what other programs are running, that sort of thing. So now we've added our 4th track of audio, guitar. We've put a couple of effects, flange and distortion, on it, and now maybe when we want to mix it down and make sure things are sounding right. So we can see that we brought up the mixer window and we'll be listening to it. So obviously this is the volume of the drums. Let's say we decided they were too loud, and I mean this was the bass and these are the drums, so we could bring the drums. And the nice thing is that then we can apply these panning settings to any of the tracks. So this is a pretty guitar-oriented mix that we're doing. And now that we've got the mix that we want, we can choose this option to save the wave as a stereo mix. Ultimately, if we wanted to put this thing onto a audio CD, we'd need it as a stereo file that could be read by typical CD audio. So we can merge audio tracks to stereo wave file. So this will take all of our 4 audio tracks and save it as a stereo wave file that could be played in something like the media player, or basically any kind of one. So we'll call it one stereo. So now this is merging all the tracks that we've made using the mixer settings that we set with the volumes and the panning the way that we want it. So you can see that you can add effects and include volume and panning settings and basically mix things down entirely using a sequencer. Now we can use a standard wave file player like the media player to find our wave file, which we called one stereo wave, and it'll play our mixed down wave file that we made. So you could convert this to real audio or whatever type of file format you use. Now if you recall, we did this particular mix, pretty guitar oriented mix, meaning the volume of the guitar is louder and you can hear our effect of flange, and then we added a little bit of distortion to it right there as well. So if we don't like anything about that, we can certainly go back and reload the file in again, and you can see even though it's a 40 meg file, it loads very quickly and is ready to be played very quickly. You can jump to any section of the file and just play it from that part, or you could go to the MIDI track, find out where we played our MIDI data, and continue to add tracks. So this is what we mean by a digital audio sequencer and MIDI integrated sequencer. Let's start with a blank sequence and we'll see some of the preferences that are available for audio settings. First of all, you can choose between if you want your project to be a 44 or 22K project. So obviously the main difference is 44 will give you much higher quality sound in the higher frequencies, but at twice the amount of memory space. on your hard drive. These settings here, DMA size, DMA offset, these are advanced settings that you can read about by pressing the help button, and they refer to if you are having specific problems with your sound card, or you really want to fine-tune things, and these affect these sort of settings, track buffer size and this sort of thing. Output buffer is whenever PowerTracks is playing the information, it's reading it from your hard drive. So this says it should read 4 seconds into memory. The significance of that is that any change you do in the volume will not take place for 4 seconds. So if you wanted to reduce that to 1 second, and then a change that you make will be heard within 1 second. Mind you, there's another setting called quick volume change that will have the change occur immediately, though you'll hear a slight glitch when you sort of reduce the volume. You'll hear a little glitch and then it will appear. So you have a choice between probably a small buffer size of a second, leaving the quick volume change off, or turning the quick volume change on, and then you could have any kind of a size. You can choose to record from either the left or right channel on your Sound Blaster type card. This is an important setting that PowerTracks, whenever it's piecing together all these WAV files, it writes typical standard WAV files as temporary files and stores them in a temporary directory that you specify. You should use your hard drive that has the fastest directory, fastest hard drive access time. So if I happen to have an E drive that was a SCSI drive that was very fast and had lots of room on it, I should type in that particular path there. Or if I wanted to type a different path now that I would want to store things in audio, it'll create that directory for me, and then I'll be able to use that directory from then on to store the audio settings data. So this setting of full duplex, if you have a Sound Blaster 16 or an AW32 or an AW64 card, you have a full duplex card, which means that you're able to record and play audio at the same time. It would be pretty bad if you couldn't record and play audio at the same time, because you wouldn't be able to hear what previous tracks you'd done. Nevertheless, this was the case with the Sound Blaster Pro cards and the early Sound Blaster 16 cards. If you have a Sound Blaster 16 card, make sure you have the latest drivers which have updated the ability to be full duplex. PowerTracks will let you know if your card isn't full duplex, and in that situation you wouldn't be able to play and record at the same time. Advanced MIDI to audio sync should usually be checked, and that just means that the audio and MIDI will be synced to the nearest 1 millisecond. We're at the Windows desktop now. We're going to talk about audio drivers and MIDI drivers in Windows 95 and how to configure them or change them or examine what their settings are. For PowerTracks to work properly, you need a MIDI driver, which is going to play those are the synthesized notes that you can use using notation, and you also need an audio driver which uses your sound card, and that's for actual recordings like your voice or guitar or saxophone. So let's see where those drivers are on a typical setting and how you can change them. First, they're all set in the control panel, and there are 3 areas that control them. The first is the Add New Hardware allows you to add new drivers to your system. The system allows you to change the settings and examine the settings of the drivers that you have added, and the multimedia is the one that lets you choose among various drivers that have been installed. So first of all, let's click on that one. That's one that you probably should become familiar with. The audio tab is important, and the MIDI tab is important. These other settings, video, CD music, and advanced, are not particularly applicable to PowerTracks. The audio setting tells us that for playback, the volume will be a certain setting, so you can change how loud your sound card is right from within this, and that you would like to use this device. Now most people are going to have one sound card like a sound blaster, but if you happen to have two or more, you could change the device that's used. The same idea applies to recording, that you could, if you had more than one sound card, you'd be recording from something different than your sound blaster. This particular setting here is not used by PowerTracks because PowerTracks will choose what recording based on the settings that you play in PowerTracks. MIDI, this is important. MIDI output will tell us which device should be the default. If you're, say, on the internet using a browser and you just click on a MIDI file, suddenly it's going to have to play using some driver. So this used to be called the MIDI mapper in Windows 3.1 and probably should be still called the MIDI mapper in Windows 95, but they haven't really given it a name other than MIDI output. So this allows us to say that we would like to use any one of these drivers for our output. So we're going to choose MPU 401 compatible, and this means that if we click on a file in Internet Explorer or we let the media player play it, it will play using this driver. So these are the settings for the multimedia. Now this assumes that we have drivers. Let's say we got a new sound card and it didn't have any drivers with it. We'd need to click on Add New Hardware, and then Windows will either search for our driver or we will prefer to install it ourselves from drivers that we know Windows has. Usually I prefer to do it by picking myself, and in the case of a sound card you would go down to Sound and Video Game Controllers and you would go down to the manufacturer of your card, which might be Creative Labs, and then you would choose Sound Blaster a 16 or AUTH32 if that's the model you had, and then you would just continue. Now obviously we already have this driver, so I'm not going to continue with that demonstration, but there's a lot of Microsoft drivers available, such as the MPU 401 compatible. If you happen to have a Roland SCC1 card, that might be the applicable one to use. But the other thing is, if you have a disk from your sound card, you could just insert that disk and the driver will be installed at that point. So now we have these Sound Blaster drivers installed in our system and a Roland MPU 401. The question is, where are they installed, what IRQs, what DMAs, etc., etc. So it's in this system that we find out exactly where they are installed. So on the we see there's these tabs for Device Manager, and this is the key one that tells us what's going on. If we click on our computer, we find a lot of very interesting information. Number one, we get the IRQ usage for our entire system. So this tells us that IRQ5 is being used by the AUTH64, IRQ7 is used by this extra MPU 401 compatible SCC1 card that we've got installed in this computer, COM4 is being used by our mouse, etc., etc. The keyboard and the timer are using these things. So if somebody says to you, I think you have a IRQ conflict, then we will be able to verify that where it's true. For example, here you see a mark on this IRQ7. That means that there in fact is a conflict on the IRQ7, but we're not using our MPU 401 compatible for input, we're using our joystick, so this conflict, although present, really has no consequences on our system. But if we tried to use our SCC1 for input, this is telling us that it was probably going to conflict. Obviously we'd never want to set our MPU 401 compatible to IRQ8 because that's using the clock, or 6 for the controller, etc., etc. But basically if you look on this and you don't see any conflicts like this, you know that your system is clean. DMA channels are used by your sound card. Your sound card is sending audio in and audio out, and each of these requires something called a DMA channel. So it needs two if it's going to have audio in and audio out at the same time. Now the Sound Blaster uses DMA channel 1 and 5 typically, and channel 1 is what's called a 8-bit DMA channel, and channel 5 is called a 16-bit DMA channel. 16-bit is much higher quality sound. The Sound Blaster would probably be better off if it could use both 16-bit DMA channels, but they're just not available on most PCs. So it has to compromise and use one 8-bit and one 16-bit. What this means to you is that when you're using PowerTracks with a Sound Blaster, when you are recording and playing audio at the same time, the playback will be 8-bit and the record will be 16-bit. This means that your record, it remains at very high quality, but the playback you hear is pretty grainy when it's happening, and that's the reason, is because of the DMA buffer. This one has to be 8-bit and this one has to be 16-bit. The good news is that when you're finished with your recording and you're just doing playback, it of course uses the 16-bit. So the only consequences of this is, as you're making your recording, if you're using a Sound Blaster, the playback in your ear, in your headphones, sounds a bit tinny, although the record quality is not affected at all. So that's the settings present in the computer. Now you can go down and specifically examine this information. This is the Creative SB16 compatible one. These other ones refer to the joystick settings. This refers to their wavetable synth, and this refers to this MPU-41 compatible we have. So we could examine the properties of our Sound Blaster card by looking at the resources. This tells us that our Sound Blaster is using IRQ5, DMA channels 1 and 5, which we've talked about, the 8-bit one and the 16-bit one. It's using port 220 for certain functions on the card. For the MIDI interface, which is at the joystick port, it's using port 330. And for other functions, such as the FM synthesis, it's using 388. Now, if we wanted, these are what are called automatic settings, which are set by the card automatically. If we wanted to mess around with things, we could deselect this and we could change the settings to different settings, changing all sorts of things on our card, or we could press the change setting button to directly change the IRQ to something else. And we can see down here that it's telling us that it'd be a bad idea to set it to IRQ7 because the MPU-41 compatible is using this already. And we can change DMA channels, and we can change port addresses, etc., etc. Obviously, you don't want to do this unless you have a reason to be doing it, and you should certainly be writing down what the settings are. And in this case, if you've mucked about with them, make sure to press cancel, and you'll be still in business. So these settings are very useful to know. Add a new driver, modify your driver settings, and once you've got everything working, you can safely be revisiting these devices to change your default MIDI mapper setting to what you'd like to use, or change your audio device volume, etc., etc. You'll notice that there's also an advanced setting which applies to possibly some audio devices, and you can explore that on your own. Typically you'll see another setting on here, which is the volume control setting. Now that's something that's very useful for audio recording. We've got all the options up here, such as microphone line in, and sometimes you need to choose the advanced controls to bring these up. But once you've got them all up here, you can see that this is effectively controls what your sound card is doing. For example, when you're using a Sound Blaster and you're using the Sound Blaster synth, you can control the MIDI volume. Now, if you're using the joystick port as MIDI, this has no effect. But if you're using their built-in synth, you can make it louder or softer. softer. Similarly, you can do the same thing with wave sounds on the Sound Blaster, making them louder or softer or muting them. The wave synth is some software synth that comes with the Sound Blaster and that we're not particularly using in this demonstration. This applies to our digital audio because obviously we're able to record from the Sound Blaster, and we want to either plug a microphone in, or if we have something like a mixer, so we'll get much better quality sound, an external mixer, then we'll plug the mixer into the line-in jack on the Sound Blaster, and these let us set the volumes of the line-in input and the microphone input into the Sound Blaster. So you can see that there's some settings that you can add various icons, etc. onto this palette of information here. But in general, you probably want to see all these ones that you're going to be using for digital audio, and it's easy to access this from the little speaker icon that looks like these speakers that's right on the bottom of your taskbar.